Hey everybody. Well, you know what this is. I got them today and couldn't resist. I had to see how these boards would come out. I got 5. They sent me 12. I mean, shit. Thanks, guys. I just hope that I don't have to bodge these, because that would be a crying shame that 11 of these are would go to waste, because I mean these things look phenomenal. I mean, they really do. I'm very very happy with this. I mean, these things look friggin' great. Anyways, the thing people ask me about, like the mounting. So there's the holes, the vias, and that just pops in there. It's a little tight. I could have made the drills a little bigger, but that's all right. It works fine. One size up. So anyway, I partially stuffed one, and now I'm going to smoke test this sucker because I haven't powered it up. I have no idea if it's going to even power up. And if it passes the smoke test, I'm going to walk over to the other computer and I'm going to flash it, and we're going to see what happens. So anyway, I'm just using the power supply, the current meter on the power supply. So here we go. 12 volts going into it. 60 milliamps. That's about right, because the display is not up because there's no code. So the default configuration for the 18 megas is internal oscillator, and so on and so forth. So I'm going to do right quick, because I'm going to check some nice voltages here. We're going to see what we get. So across this cap, that should be 12 volts. That I haven't put the cap in. It is. This should be 5.03. Good. This should be 3.3. 3.29. That's good. All right. So nothing's getting hot. So I guess it passed the smoke test. So now, if you guys will bear with me for just a moment, I'm going to walk over to the other bench and I'm going to flash it. Oh, come on, JTAG cable. Where are you? There we go. Oh, fuses. External crystal oscillator. 65 milliseconds. No clock. I can talk to it, so that's a good thing. No clock device. Yeah. Okay. Got the fuses set. Let's flash the code. It's flashing the code. So, and that was successful. So now we're going to see if this sucker comes on. So let's just walk back over to this side of the room. Sorry about that. Other bench is where I got the computer. The computer on this bench isn't working. I need to sort that out. So since it was successful, this should just come up and it should just have some defaults on the screen. So let's watch the screen and let's see if we get anything. Oh, gotta love it. So there we go. It works. Now I just have to hook up the controls so that we can actually see it work, because right now I don't have any of the encoders to all these pin headers are over on the other sides for the encoders. I gotta wire up the encoders and put this in the radio. It lives. So doing great so far. Now, I didn't stuff all the parts, like all the stuff over here that determines the mode of the radio. I didn't do that. All the stuff over here that makes up the noise toy, I didn't do that. The only thing I stuffed was the I2C circuits, things like that, so that I can get the display and I can get all this other stuff up and running. So anyways, got to put the filter cap on. I just, like, why? I'm going to make sure that doesn't smoke first, and then I'll put the rest of the parts on it. So there you have it. Now, anyways, while I'm at it, we'll just disconnect this guy and pull off the display. Set the display off to the side. here is a radio. This isn't the radio, but it is a radio. Now, the board will mount in here just like this, and you know, there's a set of holes on the height here at one height, and then there's another. You probably see them there. There's one of the sets of holes. There's another one there under this label here, but they're right here where this notch is. So the board would either be here or here. Now, the bottom of this is flood filled, and it's via stitched to death over where the RF stuff is. So there shouldn't really be a whole lot of leakage out of that. And then, of course, that comes down off of there. That'll go from a piece of coax down to the board. There's a test point in here. Incidentally, I believe it's TP1 down there where I can just stuff the coax in. I think that's where, I'm pretty sure that's where I was where I was putting the frequency counter before. But now I have to inject my signal in at that point from here. So once I get the rest of this all stuffed and put the encoders on it, then I'll it'll be this radio. So what I'm thinking is that this goes in here, you know, at say about that height. You know, in other words, at the second set of holes down. My thought is to try to get it, you know, reasonably far down enough in there, because I think the other one came a little close to hitting the speaker. So, you know, when the cover's on. So if it's down this low, it shouldn't really hit the speaker because it's at the same height as this crystal filter is at that point. So anyways, I guess I could show that mounted in there because I have been asked about the mounting, but in this absolute frickin' horrid mess that I have in here, I'm not entirely sure what I did with the screws. I'm almost positive I didn't put them away because I seemingly haven't put jack shit away lately. So, well, I don't honestly know what I've done with those screws. So, yeah, I guess next time, unless they just sort of pop out here at me, which I kind of doubt. But anyway, the screws that would just go in here, fairly standard screw, and just screw it in there, and you probably, I know that's not going to show up on the camera, but that's perfectly aligned. You just pop the screws right there in the side of the radio, board's mounted in there, run this power. The power input on this, with consumption and everything like that, because I cheated on this first one a little bit just because I wanted to try to do it, you know, make it quick. So I cheated a little bit, and I used some you know, some regular linear voltage regulators. Now, what that means is I'm kind of limited at what you're limited at what you can stuff in here. You know, you should be able to, according to the specifications for these regulators, these LM 1117 regulators and whatnot, these are, you know, low dropout regulators. They should be okay to, like, you know, 20 volts or something like that. But the problem is, if you stuff 20 volts in here to drop it down to 5, that controls the logic, the display, and everything runs at 5 volts. The main microprocessor. The RF components run at 3.3 volts. So if you're going to stuff 20 volts into this thing, or even 15 volts, I did 12. If you stuff 15 volts in here, you know, you're going to make more heat. So that's kind of the problem. You know, voltage drop across those regulators, you know, they're not buck boost regulators. So I figured it out with the heat. Now the tabs on these, not on the 3.3 volt one, but on the 5 volt one, which is DPAC, that 5 volt linear regulator, that tab's ground. Actually, that's not a 117. This one's a 1117. This one's actually just the 7805. The pad is stitched through to the bottom of the board, 1 for ground, 2 for thermal dissipation. This thing shouldn't get hot because this thing should no more on that 5 volt rail, shouldn't draw any more than like maybe 80 milliamps at the most. Right now, with nothing connected to it, it's 50 milliamps right now. The display, I want to say, adds like another 20, and you know, that's about it. I mean, really, that's you're pretty much topped out. So I'll plug the display back in. Let's make sure I plug it in the correct way. No death to displays, and it's not going to initialize that display because it was not there at power up. So now the display is going, and now it's 60 milliamps. 60 milliamps isn't going to be near enough to tickle that regulator. Now I can sit there and let that cook for a while, and even though we're 12 volts in, I mean, I can go ahead and make that up to 15, and it's still 60 milliamps, obviously. But I can just see how warm that gets, and it's cold right now, and I don't suspect that it'll really get very warm at all. In fact, not at 60 milliamps. I went a little overboard on the linear regulator, just because. The other side of this particular coin is the reason for that. Another reason for that is cost. If I went and, well, cost and space. I saved a lot of space on this for the RF stuff. So if I go buck boost and I got inductors and I got all kinds of other stuff to worry about, it's getting warm now. But it shouldn't get much warmer, in fact, than where it is now. And that's with me stuffing 15.2 into it right now. It shouldn't get much warmer than this. But I'll sit here and I'll let it cook for a while, and we'll see. But and then I'll take a measurement, a temperature reading on it, see how warm it gets. But it shouldn't get very warm. This is cheaper than going and getting a whole bunch of buck converters, which I have. I mean, it's not like I don't have them. I've got piles of buck boost, all kinds of switch power supply stuff. It's just that, in all honesty, these DPAC 7805s, I think I've got like 500 of the damn things here. And it's funny because Mike from Mike's Radio Repair, he's talking about the capacitors in the radio, and I'm going to wholeheartedly admit that I did that me having so many of those DPAC 7805s influenced the power supply design of this. It definitely did. It ain't getting any warmer. It just ain't getting any warmer. Where is my infrared thermometer? Here it is on the other bench. Fancy that, where I do most of my work anyway. Alright. So, first reading we'll do for Americans. There it is. That's perfectly okay. There's for guys like me that do things in metric, 38.9. So that's okay. Well, right there it's 40. Okay. So 100 and just over 100 degrees. That's okay. I'm not bothered by that at all. It needs to get a lot hotter to be more of a concern to me. Like, what's the microcontroller read? 88 degrees on the micro. Fahrenheit, of course. 32 C. It's just, yeah. I mean, I'm not worried about the thermal about the thermal design of it. It's fine. Nothing wrong there. I figured that it was probably this thing was probably gonna run. I actually figured at least 105. But even if it was an 100-degree radio inside of a car, I still don't think that we're going to get too hot. You know, that it can't deal with it, because it's got this huge ground plane to dissipate heat over. And of course, that's, you know, one of the biggest reasons that that's really helping right now is the fact that, you know, it's got such a big ground plane on the bottom for it to sink to. So anyways, guys, there it is. I just need to, you know, finish putting the stuff together on it, get the encoders all wired up, you know, and put it in the radio, and that's it. Put it in the radio and find out how well this thing works. I still need to write code. I have not gotten to it, so I'll just go with the crappy code that's in there, that the channel portion of it doesn't work right. There's a problem with that, where the big encoder is just not changing the channels quite properly. But I can use the VFO part of it. So anyways, that works. So next video, we'll have it in radio, I hope. So till then, thanks for watching. Catch you later.